Hey, this is Nakasuja Gertrude, and I've come here to present my work to you, sir. So with the AI coursework that you gave us, I decided to do an AI project dealing in loan eligibility using AI. Loan eligibility, first of all, is defined as a set of criteria basis which a financial institution evaluates to decide the eligibility for the customer for a particular loan. Now, with the AI that we are supposed to create using the project that we are supposed to do of AI, it should be able to solve this. Now, the types of data to solve the problem, first of it all, we need the numeric data, because it's made out of the figures and measurements gathered by machine, sensors, or people. This helps in the loan computation. You have the text data that is gathered via the scanners or digital documents, or its organized linguistically relevant characters, words, sentences, and concepts. These ones, they include like documents like land title. Someone can bring a logbook as a collateral. Actually, in text data, it helps more, especially in bringing collateral. So with the visual data, remember, they have to see some of these things physically, such that they can get the images of the collateral that they have really brought to the bank, or they have really scanned to send to the bank for them to get the loans. Now, there is a difference between supervised and unsupervised learning. First of it all, supervised learning, the machine is trained using labeled data. What is labeled data? The algorithm learns from labeled data, training data, and predicts outcomes for the unseen data. What they do, those algorithms are just labeled, actually, like they are given to that AI, such that when it looks at something and relates with what it has, it automatically detects that that's what it wants. Then for the unsupervised, it has a lot of logarithms in it. They are not clear, but on looking at them, it keeps on matching with whatever it is having, such that if they are the same, then it gives you the results. With this unsupervised, in most cases, it can make some mistakes because the data is not labeled, it is unlabeled. Maybe, like for example, it can be an apple and it says as a pie because it has the shape of an apple, and then it gives you the result of an apple, which is not true. In my project, I'm most likely to use the supervised learning techniques used to solve, because there are some two techniques that I'll be using, and they are important. First of it all, the classification algorithms. This one is a predictive modeling problem where a class label is predicted for a given example of input. Machine learning models can learn to identify patterns that are predictive of loan default by using data from the previous loan applications. Then these patterns can be used to automatically determine the amount of loan to be given to a new loan applicant. Remember, like we have said, since this data is labeled into an AI, so this machine will be able to predict the previous loan repayments and everything. Whether this person has a default that he didn't complete in the last previous loans, such that they can predict, or the repayment period was so bad, or there were delays in repayment installments. That machine can determine, such that they can predict whether this person is a very good payer and the amount to be given to him or her as a person. So for the regression algorithm, for it relates the dependent variable. It relates a dependent variable to one or more independent variables. So this one helps to take a final decision based on some binary output. Now they will relate and see, according to the repayment schedule or according to the repayment history, is it good for this person to be given a loan? If not, then we shall not give what? A loan. If yes, then they can give a loan according to the repayment history. That AI can print out the repayment history that helps them to see the eligibility of a person, whether he can be given a loan or not, depending on the history within the bank. So the unsupervised learning techniques that I'm going to use, I have the clustering. Now this clustering, for it is going to, remember, this is now the unsupervised learning techniques. Now this one just provides us with the efficient decision making by grouping large voluminous data sets in financial institutions. Remember, we have to get the details of a person. The details, now when we are clustering, sometimes we cluster according to age, according to sex, according to the salary scale, according to everything. So when we are doing clustering, we shall do the clustering of an individual, depending, we shall feed in that AI, that clustering type, such that for it can be able to detect a person, and then it shows you that this person falls in this limit of a loan, that this person falls within this limit of a loan, depending on the data that we have just gathered and clustered together. Then that AI will be able for it to gather everything and brings out the result. Then association rules. This one involves the use of machine learning models to analyze data for data patterns, for patterns or concurrences in database. Applicants with high income have high chances. Now we are just associating. If such and such a person is getting such amount of money, meaning you can be able to access this. Then basically the association rules, that's what it does. We are just going to get the information from the data set. A data set now in this case is an applicant. Now we start relating with our clustering and we see where this person falls. Yes. So the technical challenges that are likely to be faced by my project. First of all, there is the explainability issues, like how to explain the things, like telling a person whom you are going to create the system for. Sometimes it becomes very difficult because of the technical words used. So it becomes very difficult, and some of these people won't understand how the things work. Remember, if we are to make this AI, it's just going to be an application that is easily accessible by every person. Not every person knows these technical words that are used in an AI. So in a layman's language, it means that it might be a little bit difficult, and that one even will delay the usability because of the failure to understand what the technical terms means. Another thing is that, like, creating an AI is really expensive and it's rare, because sometimes the software that we need is not available, and if it is available, sometimes it is very, very expensive, in that by the time you finish, like, producing an AI, selling it to a company might end up being very expensive compared to what you thought it would be. There is AI integration. In most cases, the companies you want to sell this AI to, they have the previous systems that are already running. Now, merging these two systems into one, sometimes it is very difficult, because sometimes the AI you have built, maybe it is a high performance AI, yet the existing system is a low performance AI, and yet they want to use them at parallel or coexisting, not until they are sure of the performance of the one that you have brought. Now, the possible solutions for the challenges is that we can create the user manuals with simple English that explains the AI for cheap usability. So we try to explain the technical terms into a layman's language for such that everyone can understand. We can be trying to use some software that is not too expensive, and even we can be buying the off-shelf software and we customize it into our preferences. So with the integrating issue, we can keep trying and testing the integration of the new AI with the existing system before the actual deployment, such that we can be sure that this system they can move at per -1, causing havoc to one another. This can even help the developers to find whether the two systems can merge perfectly. So the differences between accuracy, recall, precision, and FACOS. Accuracy it means how close the value is to the true value. Remember, when you are doing things, there is that value you get, but we are going to relate how close is it to the true value. Then recall is a metric that quantifies the number of correct positive predictions made out of all positive predictions that could have been made. So we are looking for the correct ones. We made so many positive predictions, but now we are looking for the correct ones that are really applicable to that AI. Then precision is how repeatable a measurement is. How are we going to repeat that measurements in different data sets? Then FI score is a measure of model's accuracy on a data set. So appropriate AI evaluation metrics, we have classification accuracy. This is a metric that summarizes the performance of classification model as a number of correct predictions. Now we just get the number of correct predictions, we divide it by the total number of predictions. That is the classification accuracy. Then the logarithmic loss is just an indicator of how close the prediction probability is to the corresponding true value. So if it is diverging, meaning there is a big logarithmic loss. If it is converging, then it is small. Then area under a curve, we are now measuring the ability of a classifier to distinguish between classes. Now this one, it helps in the loan credit default predictions on loans gave out. We can see whether if the curve is merging very well or if the prediction is becoming higher for the defaulters.